Welcome back to my favorite people, and thank you very much for watching this lecture video. In this lecture video, we're going to go through a Grignard reagent, and a Grignard reagent like lithium aluminum hydride or sodium borehydride. It can be used to reduce a carbonyl group, or also we can turn an alkyl halide to a strong base or strong nucleophile and run some E2 or SN2 chemical reactions. And the way this reaction is going to run, and we will treat the alkyl halide with Mg, and Mg gets inserted between the halide and the halide and the alkyl. And because electronegativity of carbon is higher than electronegativity of Mg, in that case, we're going to say carbon will have negative charge. So that means this piece is going to have a +1 charge. And because R, it has a negative charge, R with a negative charge, it will be a strong base and a strong nucleophile. Okay. Now, I'm dealing with really unstable, like technically base or conjugate base. And in order to keep that conjugate base alive, I need to have dry solvent. And so that means no acidic H. And I need to use a protic solvent. Or how about this? Non-polar solvent. Right. Non-polar solvent is the best. And when I say a protic solvent, I mean no acidic H. No acidic H. Okay. Because the second you expose it to H, you will see that it will die very soon and you will lose that actually reagent. Okay. Now, the reaction is going to run through this way, technically carbon. Okay. Between carbon and halide, we're going to have Mg. So I have a carbon here. This carbon, it will be attached to Mg, and Mg, it will attach to chloride. Carbon, it will have -1 charge, and this piece is going to have a +1 charge. So carbon, it will be a strong nucleophile or base. We can run such a chemical reaction with aromatic instead of aliphatic. And if you run such a reaction, the aromatic compound, okay, and it will lose the bromide, and Mg, it will attach to the ring, and then we will have the bromide attached to the Mg. Entire of this piece, okay, is going to have technically negative charge, and this is going to be the nucleophile. Okay, so our nucleophile, it will be a ring, okay, that it has a negative charge on outside of the ring. Okay, negative charge outside the ring. Okay, I said you need to be sure that your solvent is completely dry and there is no moisture in it, or there is no acidic H. Why? Because if you reacted with acidic H, you will get Rx. The pK of Rx is around 50, and while the pK of water is 15 or 15.7. So what will happen? Reaction will move to the side that has a bigger Ka. Okay, that means we are creating more, like technically more stable conjugate base. And so R with negative charge is less stable. And this piece, okay, let's say the OH is more stable. Why more stable? Because the negative charge is sitting on oxygen versus carbon. And then we know electronegativity of oxygen is higher than electronegativity of carbon. So if there is a chance to put the negative charge on oxygen, then the reaction will do it. Okay. And as I said, okay, whenever you run the reaction, be sure to not have any trace of acidic H. Otherwise, wherever you have halide, the halide will be replaced by acidic H. And if I run the reaction with water and replace hydrogen with deuterium, wherever we have halide, it will be replaced by hydrogen or deuterium, whether it's aliphatic or aromatic. Okay, let's practice some example. And we have a carbonyl group, and we're going to treat it with a Grignard reagent, and this one is going to be our nucleophile. I'm going to highlight the nucleophile. It will be CH3 with a negative charge. So first step of the reaction is going to be this. Okay. We will have a carbon, and this carbon, and this carbon. Okay. It has hydrogen. Now, here you go. That's hydrogen. We added CH3 to it. CH3 is coming with a negative charge. So what does it mean? It means those 2 electrons, they will be taken and given to oxygen. Remember, oxygen already has 2 lone pair. If we take 1 more lone pair, now oxygen is going to have -1 charge, and the CH3 is reaching the carbonyl, and it can reach it from the top or the bottom. So I'm going to say carbon with a 3 hydrogen and a negative charge on it is behaving as a nucleophile and attacking the carbonyl group. Second, next step, if we have acidic H, so we're going to technically add the acidic H to second step. This is going to be second step. Our nucleophile or oxygen very soon is going to go after hydrogen, the acidic hydrogen. It will take that hydrogen and it will give us such a product. So we will have carbon. Our carbon now is going to be attached to OH. We have hydrogen there and CH3. So what did we get? We got a secondary alcohol. Remember, we started with aldehyde. Okay, so aldehyde turned to technically turned to a secondary alcohol. Okay, and we did not have this before, but now we're taking aldehyde and turning it to a secondary alcohol. If we run this one with ketone, okay, this is going to be a ketone. It will be the same thing. So we will have technically a ring. And now we have oxygen there. Oxygen, it has a negative charge. So this one will be -1. We added the CH3. CH3 goes there. Okay, next step, we add H plus from where? From any solvent, and our solvent is going to be water. So this is going to be acidic H. It will be taken by oxygen, and this one, it will be the final product. So the final product will be something like this. So I'm going to put H here. Okay, now we got alcohol, and this alcohol is attached to a carbon, alpha carbon. That carbon, it has it can sense or feel 3 carbons around it. So we turn a ketone to a tertiary alcohol. Okay. Let's keep practicing more example. Okay, so we have CH4. If I treat it with a base, and that base is going to take H from it, and it will give me a conjugate base. So this is going to be the acid, and this one will be the conjugate base. Okay, another example, I have methanol, and I'm treating it with a base. It will lose H. So this is going to be the acid. Let's call this one number 2, that one number 1, and we get a conjugate base. Okay, and I'm going to call this one number 2, that one is number 1. Question is between number 1 and number 2. Okay, which one is a stronger acid, CH4 or methanol? Okay, and you're going to refer to this ARIO, and A stand for atom. You need to ask yourself, where is the negative charge? Okay, negative charge on this species, the one I'm going to highlight, is sitting on carbon. So the negative charge is on carbon. We have a carbon with a lone pair. Well, the second molecule, okay, creating negative charge on oxygen. So we have oxygen with a lone pair. This one is -1, and carbon also is -1. Okay, electronegativity of oxygen higher than electronegativity of carbon. What does it mean? It means CH3OH is a stronger acid than CH4, and that's 100% true. Okay, that's 100% true. Now I have a question from you, and the question is this: we have CH3 -1, we are treating it with alcohol, and we get CH4 plus CH3 O -1. The question is, and do you think the reaction is going to move to the right side, or it will go back? Which side the reaction, and which side the reaction is going to move? To the right or to the left? Okay, give it a thought. Great job. And the answer is going to be, it will move to the right side. And what's the reason behind it? The pKa for this one is around 50, or you can say 40, around between 45 to 50. And well, the pKa here is something around 16. Okay. Now, we said the reaction is going to move to the side that is creating a bigger pKa or a weaker acid. Okay. A weaker acid. Okay. So now that I know methane is a weaker acid than methanol, okay, if I have a chance to take the CH3 and turn it to a CH3O minus, I will do it. Okay, I will do it. So I'm going to say the reaction is going to move to this direction. Okay, why? Because this species is less stable. If we give it H, it will turn to CH4, it will be more stable, and it will create CH3O minus, and that is more stable. Okay, so the reaction is moving to the side to create the species that they are more stable. Now let's talk about this chemical reaction. First step of the chemical reaction, again, is the Grignard the reagent, and now we will have O here, and we will have O methyl there, and again you will get CH3 there. Okay, this one very soon it will get acidic H, and if you add acidic to H to it, O minus, it will turn to OH. Where is O minus? This is the O minus. Okay, remember those two electrons, we give them to oxygen. So oxygen now it has -1 charge, and this one now turned to alcohol, and the alcohol is okay 1, 2. So our alcohol is a secondary alcohol until now. Okay, so we started from the carbonyl group that is an ester, and it turned to a secondary alcohol. Now, is it possible to kick this one, O-methyl, out of the system and replace it by a methyl? Yes, if you use another mole, okay, so if you use 2 moles from the Grignard reagent, next step, this is going to happen, and we will have SN2 reaction, and CH3 -1, it will go after this carbon, and it will kick the O-methyl out of the system. So we will have SN1 reaction and SN2 reaction, and this is going to happen. So this species, it will lose. Okay, it will lose the O-methyl, and it will be replaced by another methyl group plus CH3O minus. Okay, so here our nucleophile was the CH3 -1. Okay, so how many moles did I use? I used 2 moles from the Grignard reagent, and I got rid of the O-methyl out of the system. The first one was added, the first methyl was added to the carbonyl group, and we got alcohol. Now we're gonna add another, methide group, and now that we added the second methide group, we will get a tertiary alcohol. So we started from an ester, technic functional group, and we ended with tertiary alcohol. And this is going to be end of this lecture. And thank you very much.